Lesson 6.6, Systems of Inequalities. Our essential question is, how do you solve a system of linear inequalities? Well, a system of linear inequalities is very similar to a system of equations. The difference is that because they're inequalities, you're going to have to graph the system. And then remember that when you graph a system of inequalities, you're shading a half plane as your solution set. So it isn't just a point that would be on the line that would be a solution to an inequality, it's an entire region. So a system of inequalities means more than one inequality. The ones that we're going to be working with will have two inequalities. And the solution to a system of inequalities would be the region that is shaded by all of the inequalities. So we're going to be graphing inequalities and then shading and looking for the region that has been shaded by all of the inequalities. So the doubly shaded region, because we're solving and graphing two inequalities. So we're looking for the region shaded twice. Okay, so here's our first example. Solve the system of inequalities by graphing and then name an ordered pair that is a solution. So my red boundary line has a y-intercept of positive 2. So I start at positive 2. It has a slope of 2. So I go up 2 over 1, like this. I am going to cover my entire grid. Because this symbol is simply a less than symbol, you need to remember that less than means that this line, the boundary line, is going to be a dashed line, not solid, because it doesn't have a line underneath. So it's a dashed line, and less than is shaded below, So I am going to highlight below this line. So this half plane represents the solution to my first inequality. Everything in this yellow highlighted region represents y being less than 2x plus 2. Okay, now I'm going to shift to my blue line. So my y-intercept on this one is negative 3. So right here is negative 3. And then my slope on this one, negative 1x. Negative 1x means negative 1 over 1. So down 1 over 1 to the right. And this symbol this inequality symbol is greater than or equal to, so that means I have a solid line, and greater than is shaded above. So I'm going to shade above this blue line, like this. So above the line, and then remember what we're looking for our solution is the region that has been shaded twice. So using my highlighter colors, you can tell that I had yellow and blue makes green, so I need to pick a point that is in the green region because it's been shaded by both of those inequalities. So I am going to pick a point right here, which is 3, 2. So that ordered pair 3, 2, if I substituted into both of my inequalities, would be true for both of them. So that is my solution region. Okay, the next one is going to involve a little bit of work here because my inequalities are not in slope-intercept form. So I am going to solve both of them and be very careful in the process. So I'm subtracting x on each side. So negative y is greater than negative x plus 5. Then I have to divide everything by negative 1. So y is less than, I flipped my symbol because I was dividing by negative, y is less than positive x minus 5. So negative 5 is my intercept. My slope is positive 1. It's less than, so a dashed line, and shaded below. Okay. My blue line, 2x plus 3y, is less than or equal to negative 6. I need to subtract 2x on both sides. 3y is less than or equal to negative 2x minus 6. Divide everything by 3 to get the y by itself. And y is less than or equal to negative 2/3 x minus 2. So I start at negative 2, and I go down 2 over 3, down 2 over 3. You can reverse that. This line is solid, and it's less than or equal to, so I shade below my line like this. And you see the region that was shaded twice has turned green for us. And I just need to name one point in that region that's shaded twice. I'm going to pick this point right here, which is 2, negative 6. Okay, our third example, this one is a little bit different than the first two because the slopes are the same. So let's take a look at what happens on this one and what it means. So my red line starts at 1 and goes down 3 over 1. It's solid. And it is shaded, it's greater than or equal to, so it's shaded above. So above this one. Okay. Then my blue line starts at negative 2, and it's also going down 3 over 1. So look at what happens on this one. It's really close. It's just over 1 from my first line. Very close to each other. They're parallel. This one is a solid line again. So they're never going to cross. Now, I'm going to have to pay attention to which side I'm shading, because if I was shading the greater than side again, there will be a huge area where they overlap. Now looking at this symbol though, it's less than or equal to, so I'm not shading the right hand side, I'm shading less than this one, so I'm shading over here, less than. So there isn't anything that's shaded twice on this one. There isn't anything that's shaded twice. So what that means is there is no solution. There's no solution. Now, with inequalities, when your lines are parallel, it's not always no solution. It's not always no solution, like it was when we were graphing equations. So I'm going to say this again. Inequalities, if this symbol was going the same way, if they were both greater than or equal to or both less than or equal to, there would be a region. There would be a region where they overlapped. Even if these two were reversed, if they were both reversed, if these symbols were switched around, there'd be a tiny region where they overlapped. So don't assume that if you see the same slope, don't assume that that means that there always going to be no solution, okay? All right, then this last one, before we see a couple of different situations. This last one, on the red line, I would have to divide by 2 So it's 2x minus 3, so down 3 for my intercept, up 2/1 for my slope. And this is a dashed line. And it's greater than, so it's shaded above. Okay, and then the blue one. I would subtract 4x. And then divide by -2. Remember, dividing by -2 flips my symbol. So then it will be positive 2x minus 6. So down 6 right here. And up 2/1 again. So these are parallel like the last one. That didn't work very well. Just trying to erase my shading a little bit. Okay, and this one is a solid line. And it is greater than or equal to. So greater than or equal to means that I'm going to shade above. I need to change that color. Shade above this line. So now we do have a solution region, even though our lines are parallel. So like I was explaining on the last slide, you can't assume that there's no solution because they're parallel. I'm going to pick 0, 0, because that is in my green doubly shaded region. Okay, now, this slide you do not need to put in your notes. But it's a really important one to look at because everything has been graphed for you, and it's practice on deciding which lines are graphed correctly. Which ones are graphed correctly? You could graph the system on your own on graph paper and then compare, and that would be completely fine. Or you can focus on the symbols. You can focus on the symbols that you see in these equations. So this first line right here, if I rewrite this, I would be subtracting 2x. So y is greater than or equal to -2x plus 4. So my symbol is greater than or equal to, so that means it's a solid line and it's shaded above. Solid line shaded above. So I see this equation, and I see that the line has been graphed in the same spot on all of these, A, B, C, and D, but it has to be a solid line and shaded above. I know that A is not shaded above because there's this piece right here that's not shaded at all, so that's not correct. This piece is not shaded either, so B is incorrect. So it has to be C or D, C or D. Now I can check my other line that's dashed, and just make sure that when I rewrite this, that there isn't anything that flips my symbol, because that's the only thing that I would be concerned about. Nothing flipped the symbol. Nothing flipped the symbol at all. So my symbol is greater than, which is dashed and shaded above. So dashed and shaded above, this piece would have to be shaded if it was shaded above this dashed line. So it has to be D. D is the one that is correct. The last one just says to name a point that's a solution to this system. So again, it's already been graphed for you. The double shaded region is this green region right here. So you just need to name one point in that region. So I'm going to pick this point right here. So this point would be 4, 1. So if it's graphed for you, make sure that you're able to figure out which region has been shaded twice. They may or may not use these colors like I've been using. So just make sure that you're clearly able to understand whether they've shaded above or below each line. You should be able to write a summary now, answering your essential question. Make sure that you use complete sentences and restate that essential question.